Alright, let's solve this LeetCode problem today, which is majority element 2. It says, given an integer array of size n, find all elements that appear more than n over 3 times. As you can see the examples here, I don't really know how I can explain it, but let's just move over to visualize it. But the question said, the follow-up says if we could solve the problem in linear time and constant space, which is what we are going to try and do. Okay, so I have some examples here which we'll use to understand how we solve this problem. To solve this problem in constant space and linear time, you can make use of this algorithm. You can go ahead to read more about it, but for now, I'll just show you how it works. Now, if we are asked to find the major elements in this array, mere looking at it, you can tell it's 2. But in order to use this algorithm to find the major element in this array, you can say we create a variable, we'll call it major element, but I'll just write it as m, which will be the first item in the array by default. Because if the array just has only one item in it, that item in it is the major element already. So our major element will be 2, and we can initialize another variable called vote, which is keeping track of how many times we have seen that element. So for now, vote is 1, because we have seen 2 once only. Now we have to loop starting from the next item to the end. In our next item, you can see it's equal to the major element, so we increment the vote for the major element by 1. 1 is not equal to our major element, so we decrement the vote for our major element 2 by 1. We encounter 1 again, which is not also equal to our major element. We decrement it by 1 again. Now our vote is 0, meaning 2 is no longer trending. So we can set our new major element now to 1 and initialize the vote again for it to be 1. Now we encounter a 1 again, we simply increment 1 for it. Now we encounter a 2 again, we decrement 1 again. And we encounter a 2 once again, we decrement 1. Now it seems like 2 is now the trending item. So we set our major elements again to 2, sorry. And the vote for it to be 1. Now let's try to write a simple code and see how this will work. But before that, you have to know that this algorithm will only work if the major element appears more than half the size of the array. Okay, so let's try to understand how this algorithm works with this array. So the first thing we are going to do now is to create our 2 variables, which is the major element and our vote. So I can call it major element and vote count, which will be the first item in our norms, and 1 for it. Now we'll loop starting from the next index. Let's create a variable and call it current item. Will be norms at this index. We'll check if our current item is equal to our major element. You can increment the vote for the major element by 1. But if that's not the case, we have to decrement it by 1. And if our vote ever comes out to be 0, we want to set the new major element or trending element to be the current item. And we set the vote back to 1. Now if we print the major elements at the end now, you can see it's 2. But as we said, this algorithm will only work if the major elements appeared more than half the size of the array. So now let's say we change some items here. We are looking at it. The major element is supposed to be 2, but when we run it, it gives us 3, making the algorithm no longer efficient and reliable in this case. So now let's go back and understand how we can use this algorithm to solve the majority element 2 question. Alright, so I have this example here and we're going to use it to understand how we solve this problem. And we are asked to find all elements that appear more than n over 3 times. If we reason this mathematically, there can only be at most 2 elements that appear more than n over 3 times. For example, if our n is 9, n over 3 is 9 over 3, which is 3, meaning we should look for elements that appear more than 3 times, which is from 4 and above. If we try to pick 3 elements that appear up to 4 times, it will be 4 plus 4 plus 4, making it 12, exceeding our input size, which is 9. But we can only pick at most two 4s, which is 4 plus 4, and one other item or something, making it 9 in total. So as you can see, we can only pick at most 2 elements. So based on this, let's now try to write the code for finding 2 elements that appear more than n over 3 times in a similar way we did when we are finding for only 1 element. Alright, so let's do a similar thing in finding the 2 majority elements to what we did in finding the major element here. So now the first thing we'll do is to initialize 2 variables. Let's call it candidate 1 and candidate 2. Now we want to check, also want to create the vote count for each of them. So you can call it count 1 and count 2. Now we want to look for each candidate in norms. We check if this candidate is equal to our candidate 1. Let's vote for candidate 1. So you can do count 1. We also want to do the same thing for our candidate 2. We also want to check if our candidate 1 count 1. That means the vote for candidate 1 ever comes to 0. You can do to be equal to the new candidate, and the count 1 should come back to 1. And we also want to do the same thing for our candidate 2 count. Now finally, we want to decrement the vote count for both candidates 1 and candidate 2. Then here we want to count how many times candidate 1 appeared in the array and also how many times candidate 2 appeared in the array, so that we can finally check if they appeared more than n over 3 times. So we can do that by saying count 1 And we also want to do the same thing for our second candidate. Now the next thing we'll do is to create our answer. Let's call it result. As we know, this result will only hold at most 2 items. And then we create our threshold, which will be the length of nums floor division 3. Now we want to check if our count 1 is greater than our threshold. We want to append it to our result. And also the same thing for count 2. But for count 2, we need to add one more check to make sure it's not the same candidate as candidate 1. So we can do now. Finally, we just have to return our results. Let's cross check. Just so you know, this code can be solved using a hash map too. You can try that on your own. I just decided to write it this way so it can be similar to what we did before. So now let's proceed to run the code and check if it works. So it works well and runs in linear time and constant space. So that's it for this video. See you guys on the next one.